Hello Math 7 students, we're going to continue our lesson on the math practices today, math practices 1 through 8. Last time we went over math practice 1, which was make sense of problems and persevere in solving them. We're going to continue with math practice 2. Please remember that our math practices will follow this style of note-taking, math practice number, what it says. Then we'll kind of pause and clarify any words or phrases that you don't understand before we write down what it means in our own words. Then there will be an activity or an example to help us understand what it means, and finally a reflection piece. What are you going to do to be better at this math practice? Today, for math practice 2, we are going to kind of flip-flop these two. We're going to do an activity or an example to help us understand first before we put it in our own words, because this activity really does make a lot of sense. So let's get started. Remember our notes from last time? We started with our circle map here, where we had all of the words that we came up with that describe good mathematicians. And then we talked about how that relates to the math practices. Here's our math practice 1, where we had all of our notes. And we will continue right below that, or if you would like on your own page, or on a new page with math practice 2, which is reason abstractly and quantitatively. So we're writing this down right now. Math practice 2, reason abstractly and quantitatively. And as you're writing this down, I'm sure you're thinking, man, I need some words clarified. I don't know abstract. I don't know quantitatively. I maybe could figure out what reason means, but there's a lot of words that need clarified, and that is what our activity is going to do. In our activity, we will clarify these words, specifically how they relate to math practice 2. Online students, please be aware that I am recording this as I give an actual class, so you might hear some different noises, you might hear some students' answers, and I will try and repeat those so that they make it in this audio recording. Who needs more time to write this down? Okay. Before we officially start the activity, I want you to understand kind of one of the expectations that I have for today. I want you to look at this picture, and I want you to think of words that could describe the picture without explicitly stating what you're seeing. So I don't want to hear umbrellas hanging in the air, because that completely gives away what we're looking at. Instead, what are some things that you see? As you're thinking about that, how does it make you feel? That might also be ways that we could explain it. So what are some things that you could say? Seth? Abstract? How is it abstract? Okay, and that's what I really want to see. Yeah, I want to hear words like colorful and bright, because that does help us understand what we might be seeing. If you're trying to describe this to a blind person, you might want to say things that's really colorful or it's really bright. What are some other words that we would say? Maverick. Different, okay? Was it Peyton? Beautiful. I like that word. I think that's a good one too. Now, we didn't say umbrellas. We didn't say hanging in the sky. We didn't completely give it away, but we can still kind of describe how it makes us feel. For me, it makes me feel kind of cheery because I see all the bright colors, but then umbrellas kind of represent kind of sad and gloominess because you're protecting yourself from the rain. So you might also feel kind of gloomy seeing that. Like, why are there so many umbrellas trying to protect us? So that might be something else that you could say is gloomy, or protection, because it is kind of protecting us. Daxton, what'd you say? Fear? Do you have a fear of umbrellas? I'm just wondering, where does fear come from? It's scary? Okay. So everyone understand the process today. That we're not going to be explicitly stating what's in it. We're talking more about what we're seeing, what we're feeling, but not naming the objects. So here's the little activity that I have. We're just going to count off 1 and 2. So one person will say 1, I'll point to the next person, they'll say 2, I point to the next person, they say 1, 2, you get how it goes, right? 1, 2, 1, 2, 1, 2, 1, 2. I'll give more directions, but first let's figure out who's the 1s and who's the 2s. But here's the thing, no talking until I give permission. After we do that count off, no talking. And then I'll give more directions. So we'll start over here with Dean. Dean, you're a 1. You guys have to turn around to look at me. And you guys will be the ones counting off. I won't be saying it. So Dean, you're a 1. Gabe, you are? Good. Does everyone have a number? And you know what your number is, right? Okay. Number ones. I need you to close your eyes. I'm going to show something to the number twos. And you, number ones, you don't get to see it. Okay? To help you avoid the temptation, maybe number ones. Oh, I said that backwards, didn't I? I'm sorry. Number one, your eyes are open. Wake up. Sorry, I know that was a fun little nap. Number one, your eyes are open. Read the directions up here. One, eyes open, no talking. Two, you are the ones with the eyes closed. So twos, if it helps, turn to the back so that in case your eyes do peek, then you're not peeking at the screen, you'll just see the back of the room. Okay, two, eyes are closed, yes? All twos have eyes closed. Online students, you'll just have to kind of do this on your own and you'll just have to look. You're all going to be number ones. Eyes open. Okay, here it is. Okay, back to those directions. Number one, your eyes are open. You're looking at the screen. Number two, your eyes are closed, no peeking. And here is what I want to show you. Absorb it, take it all in. Start thinking of words that you could use to describe it without explicitly stating what you're seeing. Okay, it's off the screen. So now I want you to switch. So number one, your eyes are now closed. Look, face towards the back of the room if you're going to be tempted to open your eyes. Number one, your eyes are closed. And number two, your eyes this time are open. Number twos, you're looking at the screen. Are you ready for this? Number two's looking at the screen. Online students, you're just going to have to look at both. There's your image. Think about it. What do you see? How does it make you feel? What are some words that you could use to describe it without explicitly stating? All right, it's off the screen. Now, everybody open your eyes and now you have permission to talk, but I want you to fall into this sort of discussion. What did you see without explicitly stating? What did you feel? I want to hear from the number ones first. Number ones, give me some words. Gabe. Light and dark at the same time. Number twos, does that describe what you saw? Okay. Maverick. Sharp stuff. Okay. Think about that. Number twos, does that describe what you saw? Sharp stuff. Number ones, what else did you see? Yes. Yeah, you can talk about how you feel. You relaxed. I like it. Number twos, does that also describe how you felt? Relaxed. What are some other words? Could I say nighttime? Does that describe it? And it doesn't fully give it away, right? I could say nighttime. Could you say sparkly? Okay. Any other words? Now let's switch. Number twos, what did you see and how did you feel? Again, without completely giving it away. Jamie. You felt gloomy. Okay, number ones, does that describe what you saw? Seth? Medieval. Okay, interesting. Does that describe what you saw? Daxton? Confused. Interesting. Does that describe what you saw, number ones? Jaden? Say that again. Wavy. Wavy. Does that describe what you saw? What about the words that I said before? Nighttime. Does that describe what you saw, number twos? Sparkly. Does that describe what you saw, number twos? Half and half. Okay. So now the question is, did I trick you? Did I show you guys the same picture? That's what I showed you guys. Are they the same? Are they the same? No? I see stars in the nighttime sky. I see a tree in the foreground. I see mountainscape in the background. It's because of the silhouettes. They might be there. Do you see the swirls of the galaxy? So are they the same thing? Kinda. I wouldn't say yes, but can you say kinda? Yeah, I think so. And this is exactly what we're talking about with abstract versus quantitative. I think it's interesting. You guys obviously know a lot about Vincent van Gogh in order to say things like gloomy, because he was somebody who was riddled with mental illness and suffered severe depression. And so I think that you guys had some good insight to recognize that that was kind of a gloomy thing. He did paint this from his hospital window. So interesting perspective there. But the point that I want to get to is this is an abstract version of stars in the nighttime sky. Yes? This is an actual photograph of stars in the nighttime sky. This is abstract because it is a representation that represents the real life, but is different from the real life. Quantitative is the real life representation. Let me say that again. Abstract is like the real life, but has been abstracted. It looks different. We're using maybe some different techniques than we would in quantitative, which is real life. So, and we're not going to write this down. Oh, we do need to write this down, actually. I'm sorry. This is the example that you're given. So remember in our notes where we write down the for example, write this down. For example, and all you really need to write down is W plus 6. So reasoning abstractly means that we're going to be using symbols to simplify or to shorten. So I do have this very simple equation, W plus 6 equals 11. Can you guys figure out what W is equal to? What is it? It's 5. Easy, right? How many of you guys figured it out within just a couple seconds of looking at it? Exactly. It's very simple, very easy. And that is an abstract representation. But now the question I have is, what do you think W represents in the real world? What do you think W actually represents? Does it represent windows? Does it represent whales? Does it represent widgets? Do you know what it represents? And that's the challenge, is it could represent anything. We don't know because it's too abstract. We're just using symbols, it's too abstract. So let's switch gears. This is reasoning quantitatively. Understand how it relates to the real world. The length of a rectangle is 11 inches, which is 6 inches more than its width. So what does the W actually represent? Width. What is the width of the rectangle? Now remember, this was the abstract version. This is the quantitative version. Which one of these two versions would you rather solve? Abstract? Yeah, because how quickly were you able to do that? Within seconds, a lot quicker than it even took to read this, right? This was already solved before this was even read. But does this really mean anything outside of a math classroom? No. However, if that rectangle was dealing with a piece of paper that you were folding for a project, or even if it was instead of inches, if it was feet, and you're talking about an above ground swimming pool, then maybe it does matter. It has a real life meaning to it. So the point that I want to make here is, which one is easier to solve? The abstracted version. But which one has more meaning? The quantitative. Are they both the same thing? Yeah, they're both dealing with the exact same situation, but are they beautiful in their own separate ways? Just like the painting by Van Gogh and that photograph, they were beautiful in their own ways, have different uses. Same thing with quantitative and abstract. So what are the advantages to seeing this problem abstractly, looking at just the equation? What were some advantages? Yes, Daxton. It was fast, super fast. Any other? Yes, Jaden. Say that again. It was easy. Yeah, it was easy. It didn't really require a whole lot of thought process for such a simple equation, right? Any other advantages? Okay, then what are the advantages to seeing the problem quantitatively with units of measure and within the context? Daxton again. Say that again. You know what? You know what to label your answer. Well, and I think that's because you're so focused on the abstract that you need to focus, that you're trying to pull out something important. But the truth is, you guys are going to be solving problems all the time that are in the real world, and you just use the math to do it. But I think advantages to seeing the problem quantitatively are you know what the heck you're actually talking about. W plus 6 means nothing, but seeing it from the quantitative perspective means that we actually know what is really going on. So again, we're not writing this down yet. I promise I'll get to the point where you will be writing something down, but I just want you guys to be paying attention right now. So abstract reasoning is how we do math. Reasoning abstractly requires decontextualizing a situation. That's a really big word, saying don't worry about the story, just solve the problem. Don't worry about the situation, don't worry about the units of measure, just do the steps and solve it. We represent it symbolically when we're decontextualizing. That means we're writing equations to solve, we're performing calculations, we're simplifying expressions, etc. But quantitative reasoning is why we do math. Reasoning quantitatively requires contextualizing. That means we make it make sense in the real world. We tie it back into the actual situation that we're talking about. And we do that so that we can interpret the meaning of the symbols that we used in abstract. It means we're using units of measure, we're understanding the meaning of the quantities, and finding applications outside of the classroom. Because that W plus 6 equals 11, that only matters in the classroom. But possibly knowing lengths and widths of rectangles would have some real life meaning even when you're not in a math classroom. This is the part that I want you to write down, kind of summarizing all of this, okay? Abstract is how we do math, where quantitative is why we do math. And of course, I don't expect you to duplicate these photographs in your own notes, but you might want to remind yourself that abstract is like Van Gogh's Starry Night. And quantitative is like a photograph of the galaxy. Remember that in abstract, we're writing equations to solve, performing calculations and simplifying expressions. We're quantitative, we're using units of measure, contextual meaning, that means meaning within a situation or meaning in the real world. And we're looking for ways to apply math outside of the classroom. Giving a few more minutes to get this written down. Okay, so here's what your notes should look like. We have Math Practice 2, Reason Abstractly and Quantitatively. We actually are going to talk about what this means now, and then I'll have you guys copy down that example. So what does it mean? Thinking about those words abstractly and quantitatively, let's really clarify those now that we've been through that exercise. Abstract means that we're using things like symbols. It's all the super like mathy stuff, like calculations, equations, etc. Versus quantitatively, which is real life, where we want to use labels like a student mentioned, I think it was it Dexton? We want to use labels or units of measure, because we want the math to apply to our real life. We want to make sure that we're doing math for the right reasons and solving real life problems. So with that in mind, put this in your own words. Reason abstractly and quantitatively. What does that mean? And this is your job now. This means ... This is in your own words. When I say reason abstractly and quantitatively, what does that mean? Whatever you're writing down here, remember that's going to be your homework, typing that into Canvas. So take advantage of the opportunity right now to get that homework mostly done. So all you have to do is type it in. For those fast finishers, where we have our this means, you can go ahead and copy down that example. Now, do I have anyone brave enough to share what does this mean in your own words? What does it mean to reason abstractly and quantitatively? This is a great opportunity to check your answer before you type it into Canvas. That way you can make sure you get full credit. Thank you for volunteering, Seth. Good. Reason abstract, and honestly, I think that takes care of it. You're saying reasoning abstractly is a representation of reasoning in real life, and I think that that works. Who else wants to give it a shot? Okay, keep in mind I am really picky about what you're typing in, and if I don't feel like you have a good understanding of it when you type it into Canvas, then I won't give those full points. Can I please have one more student share? Thank you. I appreciate you being brave, Gabe. Quantitatively. Yeah, it's real life, exactly. But I don't want you to get distracted and only focus on one word. I want you to tie in that whole math practice. When I say reason abstractly and quantitatively, how are we going to do both of those things? So think about that and how you can improve that, and let's go to Jaden. Yeah, I kind of like that. Abstract is really, it's like it only exists in the math classroom or when you're doing homework. We're solving equations, etc. And quantitatively means that we're really solving real life problems, but sometimes we have to switch it to that abstract in order to do that. Okay, we have our example written. And again, here's more examples of quantitative and abstract. The length of a rectangle is 11 inches, which is 6 inches more than its width. What is the width of the rectangle? That's your quantitative example. But we can abstract that and make it so much simpler by just saying W plus 6 equals 11, solve for W. Understand, it's the same situation. One of them is so much easier to solve because we took the quantitative and made it abstract. So when I actually do solve this, I would take that step of maybe I would subtract 6 from each side, and we have W is equal to 5. This is still an abstract answer, but then I take that abstract answer and I say the width is 5 inches, and that made the answer quantitative. So this, again, is an abstract answer, only has meaning in math, but I converted that and I made it quantitative by putting it back into the situation and giving it some units of measure. Quantitative. And now I need you guys to do your reflection. You specifically, what are you going to do? I can make, or I did that in the last class too. I can reason abstractly and quantitatively by what? What are you going to do to be better at reasoning abstractly and quantitatively? Give you guys a few seconds to get that written down. All right, guys, that's it. That is Math Practice 2, Reason Abstractly and Quantitatively. Please don't forget your assignment tonight is to go into Canvas and put it in your own words. Tell me what you wrote down here. This means whatever you wrote down. That is your Canvas assignment tonight. That's it. Thanks for watching, and we'll see you next time.